your General Electric GP9 Locomotive Operating Manual. Section 5, Electrical Equipment, Basic Electrical System, Full Throttle, Rated to Horsepower, Engine, Deliver the direct couple of the main gem of the main generator of the power of the engine, transform with electrical power with electrical power, connect with the 4 traction motor. The 2 motors are being located with each of the truck. Each motor has been geared to an axle. Locomotive is designed with a current voltage locate limits for the main generator of the power of the kilowatts delivered with the traction motor. Full throttle is aimed regardless of the locomotive speed. Electrical system and locomotive can be throttle is divided in 3 separate systems: high voltage system, low voltage system, alternating current systems. High voltage system and achieve the direct current concerned with moving the locomotive, the retarding locomotive, the dynamic brake can achieve the main component with the high voltage system or main generator with the traction motor with the forward backward transition relay. Shunt with the field contact with the motor, shunting contact with the reverser with the drum, and the wheel slip with the ground relay, steer with the parallel power contactors. Locomotives equipped with the dynamic brake with the brake transfer switch with the cam switch, brake grids, and brake grid blower motors. Maybe the also equipped with the power with the high voltage system. Low voltage system contains the control circuit which controls the flow of the power. High voltage system of the auxiliary circuit with the conductor for the power to locomotive lights, heater fans, fuel pumps with the main generator battery fuel with the 64-volt battery with the low voltage system, so with which the power is taken to the start of the diesel engine. Once the engine is started with the auxiliary generator, take over the jobs with the supplying with the power to low voltage system. Alternating current system include with the alternating current generator called the alternator with the 4 alternate engine cooling fan motors, 4 traction motor blowers. Alternating current system provides me with the driving accessory without using the belt with the driver's speed with the vary according to the speed of the engine. 50. The main generator. The main generator is specially designed with a constant kilowatt generator with a given amount with electrical power, will produce with the input with a given amount with the mechanical power, so with the power with the watts produced with the collision time, amperes, seemingly with constant with the kilowatt generator. If voltage increase, the amperes decrease and vice versa. Main generator voltage normally 600 volts. Verifying operation condition. Output voltage. Main generator is controlled by the extent of which the main generator is automatically excited and speed of the generator. The main generator contains with 6 field windings, starting with the battery shunt, the differential competent with the communicating. The starting field is used but only when the main generator is used with the starting motor to rotate with the engine. With regard to the locomotive operation, the shunt of the battery fields provide the major excitation of the main generator. The battery field provides the initial excitation for the main generator. Low voltage current with excited field current through the battery field with vary with the action load regulator above the varying volume string with the battery with the power output with the main generator is largely controlled. Main generator itself is excited with the shunt field. The shunt field is the high voltage field where the excitation varies the voltage of the main generator. The shunt field contact open close the circuit to the shunt field. The differential compensating with the computing of the fields of the permanently connected are a matter of the engineering design provided with the direct generator characteristics. Proper communication. Figure 502, the traction motors are directly current series where series wounded motors geared to the driving axle. Motors are reversed and chain with the direction of the current flow with the field windings with the direction of the current flow with the armature always being the same with the reverse drum and the operative with the electro-pneumatic control reverse control flow with the traction field windings. Traction motors are cooled by alternating current driver belts, blowers, one on each for the motor. The traction motors are mounted in the flow with the engine room. Blow air through the flexible ducts. The traction motor, the speed of the blowers vary with the speed of the engine is distributed with the engine speed varying with the frequency of the alternator. Maximal permissible top speed of the locomotive is limited with the same with the RPM of the traction motor armature. High speed gear ratio is required for high-speed train operation. Low speed with the rear ratio needed to serve the full horsepower. Low speed with the tonnage trains without overheating, damaging electrical equipment. Reversing a locomotive, moving the reverser lever forward, reverser energy of the respectively. Forward reverse magnet valve with the reversing located with the electrical cabinet. Figure 6 and 5.1 with the either magnet valve with the energized valve with the control airflow through the valve with moving the reverser to the desired direction. 4 lengths for segments shown the reverser in the forward. 8 short segments can be seen when reverse and reverse. So there's a magnet valve, locking pin, and that's your reverser switch locked in neutral. 504 transition. The term is applied with the chain with the traction motor, electrical for the connection, all of the diesel electrical power with the obtained from the main generator, the which for the range current with the voltage limit. Looking over the wave with the transition method, adjusting with the traction motor with the back pressure, with the counter EMF with the buckling input with the power with the main generator, so the back pressure will not become too high at the higher speed, nor to the lower speeds. Standing still with the traction motor, the head practically in the no back pressure for the resistant input with the current with the main generator, the help with the locomotive speed and increase the starting of the series parallel transition 1. 528 with the back pressure for the traction motor builds up the coil with the main generator pressure voltage with the increase the they can continue forcing the current with the motors. Although the main generator can vary with the voltage over the wide range of the practical operating limit with the ability to increase the voltage with the practical voltage limit of the exceed power output of the main generator with the corresponding with the engine would drop off to prevent loss of power of the chain with the main with the electrical circuit just before the drop off again with the main generator at this time will have reached approximately 965 volts the first 2B with the transition 1 2 for the series parallel shunt context bypass shunt the circuit around each for the traction motor fuel shunting with the traction motor for the reduction and the back pressure for the traction motor, which in turn allows the voltage of the main generator to reduce itself. Show the series parallel main generator, and then your traction motors number 1, 2, 3, and 4, and series parallel shunt has traction motor number 2, 3, and 4. There's 4 push buttons and 4 induction coils to this. Power contactor 2, power contactor 3, 1, 2, 3, 4 switches, adjustable rheostat on the series parallel, fixed rheostat on the series parallel shunt, fixed adjustable inductor resistor, series parallel just adjustable inductor. With constant KW voltage goes down, the amperage goes up, the vice versa with the shift the transition to more current with the capacitor with the traction motor armature maintaining the full power outcome put over the locomotive. As the locomotive speed increases, the gain tendency of the power to drop off at the time of the main generator reaches approximately 965 volts with the complete chain with the electrical circuit necessary to once again reduce the back pressure over the traction motor, which chain with the transition to the 3 parallel with the figure 5 of 3 is complete with the main generator continuing the full application of the power until the still higher locomotive speed of the reach. At this time of the wind with the local voltage return with approximately 965 volts. Motor shutting contact again with close once again with reducing the traction motor with the back pressure effect with the transition 3 and 4 parallel shunt. Figure 5, 3, and B with the D increasing with the speed caused by the grades of the reversal sequence transition take place with the preventing C with the current limitation on the main generator. Once again you have parallel and then parallel shunt. R505 transition control circuit with the 3 relay with the FSR, FTR, and BTR actuate changing the traction motor with the connection with the fully automatic forward and backward transition. So we have FSR and full SFSR and FTR voltage operated with a BTR. Backward transition current operated device. Forward transition always made with a predetermined main generator voltage. Backward transition made predetermined main generator voltage from shunting position 4 to 3, 2 to 1, dropping out. The FSR backward transition parallel position made with the predetermined main generator amperage for the backing up of the backward transition relay. Relay contact with the diesel engine locomotive consists of the operating core with the set with the main contact, several actual auxiliary contacts called the interlocks. Interlocks could be the normal oil opener closed with the operating core with the de-energizer dropped out, or the energizing picking up the global chain with the normal position of the relay. Interlocks figure 5-4 shows no power applied to the coil. The de-energizer dropped out with the interlock normally open, interlock normally closed. Operating coil show the double push button, a battery, and an operating coil and with the switch. And then they show with the power applied, the close switch is closed with the battery goes the operating coil. In the position you have 4 wires on a 2 position throw switch. Or thus interlocking shown with the wire diagram closed position 1 with respect to the operating coil with the de-energizer of the P1AB interlocking normally closed with the opening of the P1 power contactor 1 operating coil is energized with the coil de-energized drop of the interlocker return with the normal closed position. Similar interlock shown with the wire diagram on 1 position will close with respect to the operating coil because the energized picks up when the coil de-energized drops out with the interlock with the return with the normal open position. Figure 5-5 schematic diagram transition control circuit between with the traction motor connection that takes place as follows. Here's parallel transition. Starting with the train with the traction motor, with the contact with the series parallel with the gang with the traction of the motors with the series parallel with the move with the locomotive with the proceeds valve with the plate with the control fuel pump with circuit breaker with the current no flow with the PC wire place isolation switch around move the selector level with the number 1 move the reversal level with the forward or reverse current now flows through the forward or reverse wire depending on the position of the reverse level of the switches 13 and 24 contactors club with the traction motor with the connect with the series parallel place engine run circuit breaker and on place generator for circuit field circuit breaker on. It shows the schematic automatic transition circuit. 8. Open the throttle with the run position 1 or high with the current now flow with the G ground field, wire, generator field, the starting field, the battery field, contactors club with the locomotive moves. If the train speed increase with the run 8 position automatic forward transition takes place as follows: series parallel shunt transition 1 to 2. The forward start relay picks up the approximately 965 volts current flow with the forward's FSD and the CD picks up the forward shunt relay. Forward shunt relay energy of the forward time relay delay opening with a normally closed interlock CD closing the normal opening interlock AB for the 12 seconds after the FSD with the energized action prevents sudden backward transition change figure 2-1 field shunt club with the train with the series parallel shunt with completed series parallel shunt the parallel FDR picks up with approximately 965 volts current through the FSD AB picks up the field FDR. The transistor relay picks up the TDB, picks up the TDB, backing up the increase to pick up with the BTR from 2250 plus or minus 25 amperes with the 2400 to 2500 amperes, approximately 3 minutes, preventing sudden backward transition. Shunt field and battery field dropout, shunt field dropout, insert the additional 100 ohms in the shunt field circuit, the decaying with the generator gradually. ORS, inside of the load regulator, move the door of the minimum field. TR, GH, and PI, power 1, CD, blower, dropout with the FSR with approximately 550 volts. 7, FCSR drops out. FCR drops out approximately 515 volts. Field shunt, open the field shunt with delay. The energy of the TBD drops out with the TBD time delay relay with the holes of normally iron lock with the TDB and is closed with approximately 3 minutes with the operating coil. The energized action prevents sudden backward transition change 3-1. Switch 13 drops out. Power 1 and 3 pick up the switch. The 24 drops out. Power 2 and 4 pick up steering field and battery field pick up. The ORS is the energy of the transition chain of the parallel complete with the locomotive resumes power parallel to parallel shunt. The FSR picks up the approximately 965 volts current through the P4, picks up the FSR with the FSD energy of the field shunt, closes the chain of the parallel shunt to complete with it as the speed train decrease the valve number 8 run to the 8 positions. Automatic backward transition takes place as follows: parallel shunt to parallel transition 4 to 3. FSR drops out approximately 670 volts in here with the dropout shield SS starting field of the battery field dropout FSD with the energized field switch field start open field shunt opens starter field and battery field back up the transition chain of the parallel complete with locomotive resumes power. Parallel to series parallel shunt with the battery transition relay picks up the 2250 plus or minus 25 amps. The transition relay drops out steering field, battery field dropout, or SD energy load regulator moves toward minimum field. Battery transition relay drops out of the dropout approximately 83% of the pickup value. Battery transition relay drops out with the decaying main generator field with the starting field of the battery field open. Power 1, 2, 3 dropout. Switch 13 picks up power 2 and 4 dropout. Standard 4 and 24 picks up steering field pickup. ORS is de-energized backward transition chain serial parallel non-complete with the locomotive resumes power. 12 main generator with the voltage following with the backward transition parallel series of the parallel will reach approximately 965 volts for each second. The forward transition 1 to 2 from 1 to 2 will take place. Field shunt relay adjust the automatic dropout approximately with 740 volts and ensure the parallel shunt of the backward transition 2-1 will take place with the voltage drop. Alright, 506, your load regulator. Essentially, the load regulator is automatically operated rheostat connected with the shear with the battery field with the main generator. The load regulator self-contained until the which consists of the hydraulic vane type motor connected to Commutator type of the rheostat, figure 5, 6 of the engine oil for the brushing of the 4 of the vane, motive of the rheostat with the brushing of the varied position of the oil pressure and pressure to either side of the vane, the directed load regulator, pilot valve located with the engine, governor for the strip of the load regulation engine, the horsepower determined with the rate of fuel consumption merely means that more horsepower, develop more fuel with you, with the vice versa of their definite rate of the fuel consumption, each of the valve with the position engine, the loaded the rate of fuel over the consumption rated for the position of the governor power position with the control of the opening of the interjector for the reactive load on the engine should be made such that more fuel the demand will rotate the engine RPM in order of the throttle with the predetermined balance between the load and fuel consumption of the load regulator pilot valve will call the load regulator whose engine load required amount of the producing of the battery field switch engine requires less fuel for the predetermined setting of the load regulator, increase the load of the engine, increase the battery field succession of the main gem of the manner of the battery voltage of the temperature change of the generator, winding locomotive speed of the design called the overloading, underloading of the engine, constant power output is maintained each throttle setting located with the governor is overriding the solenoid ORS, which can be override with the normal action of the load. Pilot regulator valve with the overriding solenoid engine of the force of the load regulator pilot valve to change the call for the engine oil with the pressure move of the load regulator toward minimum fuel position, unloading the engine with the overload relay solenoid override relay solenoid change over the transition wheel slip action. The governor is also equipped with a 2 micro switch of the LRS and the OLS to protect against the possible engine overload. The switches are closed, which are predetermined with the high rate of the fuel consumption rate for the load LRS load relays. Switch closed with the quick starting and feature for the GP9 control engine loading and return of the load regulator. Quick starting with the feature for the effect of only with the transition of the OLS to your override load switch closed with the override solenoid energy of the moving slope of the regulator turning for minimum fuel position, reducing load on the engine. R507, the engine speed control with the throttle with the control of the 10 position, stop idle with the run stop speed 1 through 8 with the engine stop with the drum 2 to 8 with the increase the engine speed with the 80 RPMs of the throttle with the lever operated drum type with the switch with the distribution with the current with the hot wire with the 1 more than the wire depends on the position of the throttle with the governor's design with the energy of the various combinations of the governor solenoid AVBC, ABVB, CV, DV cover the engine to respond to the order of the throttle, the engine speed trouble to show the various combination series solenoids that are energy to obtain the desired engine speed for various throttle position, engine speed control of the schematic diagram, figure 5-7 show the methods of the energized various governor solenoid, various position of the throttle. Alright, your ER emergency relay with the ER emergency relay concept with the current supply with the A, B, and C with the governor control of the solenoid. The engine for the relay will cause the engine to immediately stop with the throttle with the run 5 with the 6 with the de-engine with the engine run relay with the throttle position will bring the engine to idle. To control the engine speed with the engine run relay must be energy of the engine run relay has three normal open interlock with the clove of the relay with the energy of the connect with the control circle with the A, B, and C with the governor's control solenoid 5 so the engine run relay has no control over the D governor control solenoid engine run relay each with the energy of the current with the receiver with the FB wire runs throughout the locomotive the engine running circle with the breaker with the engine control panel with the must be on the on energy of the FB wire with the main generator control switch with the must be also clove current flow through the FB wire with the AR engine run relay with the engine run circuit breaker with the must engine control panel with the on and the pneumatic control switch must be closed. Isolation switch must be on the run non-voltage relay. Relay must be energized. The engine must be running and the grounds relay must be set. Alright, 509, your battery field contactor infused. When the throttle is moved with the idle to run, the contactor clove with the connect with the low voltage excitation through the main generator battery with the battery field with the contact with figure A58 remains closed as long as the power is being applied, but that will only open during transition wheel slip action rectifier discharge resistor. Are you dissipated with a high voltage induced by the battery field with the battery field contactor is open to 80 amp the battery field with the located with the electronic cabinet protected with the battery field circuit with the fuse blown with the locomotive developed and normal power. Alright, 510, wheel slip. The wheel slip, control slip, the operation of the moment of the slip of the pair with the wheel, detecting the of the power with the located with the electrical cabinet with the 4-wheel slip control layers, wheel slip 13, 14, wheel slip S, and wheel slip R for the relay with the screw with the cable, the figure 5-9, wheel slip 13 and 24 are operated 2 with the bi-flow with the current 3 with the relay, current with the traction mode with the connect with the series parallel punch parallel shunt, current leaf flow with the relay, curl with the unmanned with the bridge, with the circle between the 200 ohm with the resist, the 2 traction mode with the relay, circuit coil with the bridge, occur with the result of slipping motor by current differential between the cable to the path of the relay frame with the traction motor connected with the parallel shunt. The cables are so the range normal current through them equal magnitude in the opposite of the direction magnitude of the field established by current flow of the one cable is nullified with the magnetic field established by the current flow and second cable when the unbalance of the current flows occur as a result of slipping the motor with the result of the magnetic field established with the accurate weights of the wheel slip relay. The wheel creep relay and wheel slip series are operated with the current differential between the cable with the pass through the relay frame traction motor connected with the series pair with the series parallel shunt. Automatic standing power occurs with the action over the wheel creep relay with the wheel creep relay detect with the very slow with the creeping type slips. The function wheel creep relay have slightly lower pickup value with the wheel slip series and wheel slip relays for the automatically apply with the channel to the rails which tend to prevent the wheel slip necessitating reduction generator field excitation. Your wheel creep relay picks up the energy over the time delay with the sanding relay pick up with the TDS automatically actuate the forward reverse sanding valve picking on the position of the reversal level applying to the sand to the rail. A very slow speed of the wheel slip cannot be corrected by the action wheel creep relay applying sand with the rail of the wheel slip series picks up the reduce the main channel of the excitation wheel slip series with the picture of the wheel slip light when the flashes on the battery field contactor will open the battery field contactor cut off of the main generator field excitation called with the overriding solenoid move the load regulator toward the minimum field position. Action will generally correct the wheel slip but it should not be necessary for the engine man to reduce the valve. Thus the function of the wheel slip series relay is to recognize slow speed of the wheel slip with the effect of the slip correction with a minimized loss of the tractive effort. Further reduction of main generator excitation is necessary to correct the wheel slip relay actuated and when the current flow through the relay coil with the pickup of the opens with the battery field shunt contact the reducer the excitation of the main generator at the point slipping step of the time delay sanding valve is the energy of the automatically applying sand to the rails when the shunt field the contactor opens additional resistance to have the shunt field circulator resulting in the further controlled unloading of the main generator of the opening battery field contactor energizing override solenoid over the load regulator moves to over the minimum field position thus soon as the slipping stop of the wheel slip relay will drop out. Power will automatically be reapplied with the lower level at which the slipping will is initiated. The application of power will gradually return designated by the position of the throttle to the correct with the high speed of the wheel slip, the traction motor with the connected with the parallel shunt. Either wheel slip relay actuated current and differential between the traction motors 1 and 3 and wheel slip 13 or 2 and 4 and wheel slip 24 will pick up the reduce the main generator excitation of the deployment of the slipping and stopping. Side slanding automatically applied with the rails during the wheel slip. The detection should be necessary for the engine man to operate with the manual sanding of the continuous wheel slip with the insane the curve of the throttle should be reduced. Alright, figure 510 show the battery switch panel. Figure 511 battery switch. Figure 510 located with the electrical cabinet connected with the battery to low voltage circuit at the start of the diesel engine. And during normal locomotive operation, main battery switch should be closed. 512, your battery ammeter. The battery ammeter is located with the rear cap of the wall with the only show the whether the battery is charged with the discharge. Normally with the meter will indicate 0 with slightly charged. If the ammeter shows the continually discharged auxiliary generator output should be checked with the battery rain run down. 513, your reverser current relay. With the reverser current relay RCR shown figure 511, the main purpose of the reverser current relay to prevent reverse flow of the current from the battery to the auxiliary generator. The reverse current relay opens the battery charging the contactor whenever the auxiliary generator voltage drops below battery voltage. The action prevents motorizing the auxiliary generator by the battery. 514, battery charging contact. The battery charging contactor is an extremely operated switch for the connect with the auxiliary generator output of the low voltage system. Reverse current relay control for the operation battery charge contactor. 515, ground relay contact. Located in the capsule of the electrical cabinet, electrical protective device called for the ground relay. 512, the function of the ground relay automatically on with the main generator and cable of the ground. High voltage system in the ground can be defined with the current passing through the frame and the car body of the locomotive. If the ground is high with the voltage shift, the curve of the ground relay will be tripped. The trip of the ground relay opens with the shunt of the field battery. Contact with the unloaded main generator with the ground relay must be reset before the unit can be again deliver power with the relay. Reset with the repressing with the reset button when the relay should be repeatedly tripping and the power is applied with the power must be isolated. Figure 512 show the ground relay. Caution isolate unit before resetting the ground. If the ground relay trips the white needle end of the relay will point to the red dot. If the normally on set position, the needle point with the yellow dot in the relay while the ground relay trip the speed of the engine will automatically reduce to idle. If the ground relay trip while the throttle was in 5th or 6th notch, the engine would stop. And although the high voltage ground would normally be on with the ground relay tripping, low voltage ground will again trip the relay with the engine start with the term that high voltage, low voltage systems are temporarily connected. Ground relay action is not necessarily an indication of serious trouble, but should be reported maintenance authority. Ground relay knife switch will, when open, eliminates the protection of the ground relay. The switch must not be open in the normal operation left to define instructions that are issued by the official of the railroad. Alright, 516, your low voltage regulator. Voltage regulator figure 513, local with electrical cabinet, engine room side of the voltage regulator performs function seeing output voltage auxiliary generator remains approximately 74 volts where engine was running. 517 auxiliary generator view of the battery switch for the 150 ampere view of the 250 ampere locomotive with equipped with steam generator located electrical cabinet figure 510 protect the auxiliary generator again with the possible overload of the auxiliary generator with the only fuse output view should be become blown in with a cutoff of the auxiliary generator low voltage system alternating currents if the demand meter will but indicate with the discharge of the auxiliary generator output fuse from the alarm bell will ring alternator failure light blue will be on and it's effective. 518 auxiliary generator field circuit breaker with the 30 amp circuit breaker located with the electrical cabinet figure 514 concept for the auxiliary generator with the field bindings with excess of the current with the dripping of the circuit breaker will prevent the auxiliary generator from supplying current to the low voltage system. The alternating current system over the auxiliary generator figure 514 so with the circuit breaker electrical fun. You have your fuel pump auxiliary field generator alternating field generator. Circuit breaker with a trip to battery ammeter with the indicating with the discharge of the alarm bell with the ring with the alternator failure light blue or blue will be on and the units affected. 519. The alternator field circuit breaker with a 30 amp circuit breaker located with the electrical cabinet figure 514 protects the alternator field windings again with a possible overload. Tripping the circuit breaker will shut off the supply of the AC current of the traction motor below with the radiator cooler fan with the circuit of the breaker trips open with the alarm bell will ring and the blue alternator field will be on and the unit affected. No AC voltage relay. As the traction motor with the cool with the AC driven below the fall of the alternator code result of the damage of the traction motor and left to application the power would stop. Thus in this case the alternator failed with a no voltage relay with a figure 515 located with the caps out with the electrical cabinet drops out with the cup with the electrical alarm bell ring. In all units, the alternating failure light blue will be on the engine speed with reduce the idle of the unit of the effective within the throttle was within 5 to 6 knots for the engine would stop with the 9 voltage relay dropping out with caused by one auxiliary generator field or alternator field circuit breaker tripped open, 2 the auxiliary generator fuse blown, or 3 the diesel engine stop while online. Figure 515 show the no voltage relay and 515. Alright, section 6, your steam generator model OK4625 introduction.